Most people think rust begins when they finally see that orange stain on a blade, a bolt, a hinge, or the bottom edge of a steel door. But rust starts earlier than that. It starts in the damp corner of a garage where the air never really dries. It starts under a mower deck after wet grass has been packed there for one more night. It starts on the jaws of pliers tossed back into a toolbox with sweat still on the handle. It starts on the underside of a trailer where road spray sits in seams no one checks until the metal has already begun to weaken. By the time you see the orange, the metal has already been working against itself for a while. And that is why so many people lose good tools before they understand what happened. A garden hoe that used to cut cleanly through soil starts dragging like a dull spoon. A clamp that once turned smoothly begins to bite and grind. A vice handle leaves red dust on your palm. A cast iron griddle that cooked breakfast for years gets pushed to the back of a shelf because one wet washing left a rough patch across the surface. None of it feels dramatic at first. That is what makes rust dangerous. It does not ask for attention. It takes small payments from your metal every day. A little edge, a little strength, a little smoothness, a little money from your pocket when you finally replace what could have been saved. Most people respond too late. Then they respond with whatever the store shelf tells them to buy. They buy a rust spray, then another one. They buy a converter in a small bottle with a bold label. They buy a wire wheel, they buy primer, they buy paint, they buy a new tool when the old one looks too far gone. And the strange part is this. A large part of the chemistry inside many rust converters is not rare. It is not exotic. It is not locked away in an industrial plant. One of the most useful parts can come as a plain powder with a plain name. Tannic acid. That name sounds technical, but you already know the family it comes from. It is related to the dry pull you feel from strong tea. It is part of what gives oak bark, grape skins, walnut hulls, and many plant materials their gripping, bitter character. For centuries, tannins helped turn hides into leather. They helped make old inks dark. They stained iron, they reacted with it, they bonded to it, and when tannic acid meets rust on iron or ordinary steel, something very useful can happen. The loose orange corrosion can be changed into a darker, more stable iron-tannin compound. The surface can shift toward that deep blue-black look old restorers recognize. The rusted layer is no longer just a crumbly warning sign. With the right preparation, it can become part of a more stable surface that is ready to be sealed. That is the part most people never hear. You are not washing rust away like dirt, you are changing the surface chemistry. But before anyone runs to the garage and starts brushing liquid on every metal object they own, the honest limits matter. This method is for iron and carbon steel. It is for the ordinary orange rust that forms on steel tools, steel frames, iron brackets, mower decks, shovels, clamps, hinges, vises, grill parts, stove parts, steel railings, old machinery, and cast iron that can later be seasoned or sealed correctly. It is not a magic coating for aluminum. It is not meant for brass. It is not for copper. It is not for galvanized metal. It is not a shortcut for stainless steel. Those metals corrode in different ways, and tannic acid does not have the same rust layer to work with. That one detail saves people from disappointment. Use the chemistry where the chemistry has something to grab. Now, let me show you the version I would actually trust in a home shop. Not the fantasy version, not the never rusts again version, the practical version, the version that can stop active surface rust, darken and stabilize it, and give you a protected surface when you follow it with oil, wax paint, or another proper top coat. That final top coat matters. The dark conversion layer is helpful, but it is not armor by itself. Water and salt are patient. If you leave converted metal exposed in harsh weather, especially near the ocean or on winter roads, the protection will wear faster. So the real promise is this: instead of letting rust eat a tool until you throw it away, you can turn the rusted surface into a better foundation, seal it, and keep the object in service with occasional maintenance. That is more useful than a miracle claim, and it costs very little. Here is what you need: tannic acid powder, distilled water, a small amount of phosphoric acid rust remover, a clean cup or glass jar, a foam brush or cheap paintbrush, a stiff brush, steel wool, or a scraper, gloves, eye protection, and a place with ventilation. Do not skip the safety part. Phosphoric acid is common in rust removers, but common does not mean harmless. Keep it off your skin, keep it out of your eyes. Do not mix chemicals in a closed room. Do not use kitchen containers again for food after they have held a shop mixture. That is basic respect for the material. The first step is not mixing. The first step is choosing the right test piece. Do not begin with the most valuable tool in your shop. Do not begin with the family skillet. Do not begin under a truck where you cannot see what is happening. Start with a rusted steel bracket, an old pair of pliers, a shovel head, a hinge, a mower blade you already removed, or a scrap piece of rusty steel. You want something honest, orange rust, no heavy grease, no thick paint, no flaky layers falling off like cornflakes. Then clean it the right way. This is where people make the first mistake. They try to remove every trace of rust until they are back to bright bare metal. That defeats the purpose. Tannic acid needs iron corrosion products to react with. If you grind everything down to clean, shiny steel, there is less rust left for the conversion reaction. You still need to remove loose material, but you do not need to erase every dark patch. Scrape away the loose scale, brush off the powder, remove mud, oil, grease, and wax. If the surface is oily, wash it with a degreaser and dry it completely. If salt may be present, especially from road spray or coastal air, rinse and dry the piece well first. Salt trapped under any coating can keep pulling moisture toward the metal. That can ruin almost any protection system. Once the surface is clean and dry, mix the solution. Use distilled water, not tap water. Tap water can contain minerals and chlorides. You are trying to reduce the number of variables fighting the metal. For a small batch, pour a little warm distilled water into your container. Add tannic acid powder and stir until the liquid turns dark like oversteeped tea. Then add a small amount of phosphoric acid rust remover and stir again. You are not making soup. You do not need a bucket. A small amount goes a long way because you are brushing a thin film onto the surface, not soaking the object like laundry. The liquid should be dark enough that you can see it on the brush, but still fluid enough to spread evenly. Now brush it onto the rusted steel. Do not flood it. Do not leave puddles. Coat the surface evenly and push the liquid into pits, seams, corners, and textured patches. Those are the places rust hides. A flat face is easy. The edges and overlaps are where the job is won or lost. Then leave it alone. That is the hardest part for impatient people. Within minutes, the orange may begin to dull, then it may turn brown, then gray, then a blue-black or near-black surface can begin to form. Sometimes it happens quickly, sometimes it takes longer. Heavy rust, low temperature, poor cleaning, or old contamination can slow the change. Do not judge it after 2 minutes. Let the chemistry finish. When the first coat is dry, inspect it. If you still see bright orange rust in spots, apply another thin coat. Thin coats are better than one heavy coat. A thick, wet layer can dry unevenly and leave weak areas. A thick coat has a better chance to bond, dry, and form a consistent surface. For small tools, 2 thin coats are usually a better goal than 1 heavy pass. After the conversion layer is dry, the surface still needs a finish. This is where the second big mistake happens. People see the dark color and think the job is finished. It is not finished. The converted layer helps volatilize the rust, but a top coat keeps water and oxygen away. Without that barrier, the metal is still living in the same world that rusted it in the first place. For hand tools, wipe on a thin coat of oil, paste wax, boiled linseed oil, or another suitable protective finish. For outdoor ironwork, use a compatible primer and paint system after the converted layer has dried according to the product and material conditions. For a mower deck or trailer part, use a coating designed for abrasion and weather. For cast iron cookware, do not treat it like a shovel. If you choose to use any chemical conversion method on cookware, you must clean it thoroughly and season it properly afterward, and many people may prefer traditional cleaning and seasoning methods instead. Food contact surfaces deserve extra caution. That kind of caution does not weaken the method. It makes the method more trustworthy. A real shop practice has limits. A trick pretends it has none. Now think about why this feels almost unfair. The shelf product looks more powerful because it has a label, a logo, a warning panel, and a price that makes it seem professional. The plain ingredient looks less powerful because it comes in a small bag with a chemical name most people scroll past. But the reaction does not care about marketing. The metal only cares what touches the corrosion layer. That is why restorers, conservators, mechanics, farmers, old house owners, and careful tool users have all paid attention to tannins and rust converters in different ways. The useful knowledge was never glamorous. It was practical. It sat between chemistry and maintenance. And practical knowledge is easy to lose, not because someone hides it in a vault, because people stop teaching the steps, A grandfather used to show a young person how to clean a hinge before winter. A mechanic used to explain why salt had to be washed from the underside of a vehicle. A carpenter used to wipe tools before closing the chest. A cook used to dry cast iron on heat instead of leaving it wet in the sink. Then convenience replaced habit, spray this, replace that, buy another one, throw it out. The real loss was not only the money, it was the habit of understanding materials. Iron and steel are not mysterious. They are strong, but they are not invincible. Give them moisture, oxygen, salt, and neglect, and they will give you rust. Give them cleaning, conversion when needed, and a barrier, and they can last longer than most people expect. That is the deeper lesson here. You are not saving metal with a secret. You are saving it by knowing what is happening on the surface. Rust is not just ugliness, it is chemistry moving in the wrong direction. Tannic acid can help move part of that surface into a more stable state. Phosphoric acid can help convert some corrosion products into phosphate compounds. Oil, wax, primer, or paint can help block the next round of moisture. Each piece has a job. When you understand the jobs, the process stops feeling like a hack and starts feeling like maintenance. Now let us make it practical. This weekend, pick one rusted item that is still structurally sound. That last part is important. If a brake line is badly rusted, do not save it with a brush and a hopeful attitude. Replace it. If a trailer part is deeply pitted near a weld, inspect it properly. If a ladder, jack stand, suspension part, or anything safety critical has serious corrosion, do not trust surface treatment alone. This method is for preserving metal that still has enough strength to be worth preserving. It is not a way to ignore structural damage. Choose a tool, a bracket, a clamp, a hinge, a shovel head, a steel shelf, a railing section, or a piece of old equipment where the risk is low and the lesson is clear. Clean it, brush it, watch the color change, let it dry, coat it again if needed, seal it. Then put it back where it belongs, not in the damp corner, not on the floor where rainwater creeps under the garage door. Not under a pile of wet rags, put it somewhere dry, hang it, oil it, check it again in a month. That final habit is what makes the difference. The powder helps, the chemistry helps, the coating helps, but the real result comes from changing the way you look at rust. Most people wait until rust becomes a replacement cost. You are going to treat it when it is still a surface problem. That is how old tools survive. That is how old machines keep working. That is how a steel gate, a vise, a stove door, a shovel, a mower deck, or a trailer frame gets years added to its life instead of quietly losing metal every season. And the first time you see that orange surface turn dark under your own brush, you will understand why this lesson stays with people. It is not only because the color changes, it is because your relationship with the object changes. A thing you were ready to abandon becomes repairable again. A tool that looked finished gets another season. A piece of metal you thought was ruined teaches you something simple and hard to forget. The surface was not asking to be replaced, it was asking to be understood. So here is what I want you to do. Look around your garage, shed, porch, basement, truck bed, or workshop. Find one piece of iron or steel with orange rust on it. Not the worst thing you own, the one that is still useful if you stop the damage now. Write its name in the comments, just the object, vise, shovel, gate hinge, mower deck, cast iron pan, trailer bracket. Then come back after you try the process and tell me what happened when the orange changed color. Tell me what surprised you, tell me where it worked, and tell me where it did not. That is how we separate real shop knowledge from internet noise. And if you want the next step, stay with this channel. Because once rust is under control, the next skill is edge and movement. A tool does not only need to be protected, it needs to cut, turn, clamp, slide, and work. Next, I will show how to bring back a dull edge without ruining the steel, why most people overgrind good tools, and how a simple stone can do more than an expensive machine when the hand behind it understands the angle. For today, start with the rust. Do not throw the metal away before you give the surface one fair chance. Sometimes the cheapest repair is not cheap because it is weak. Sometimes it is cheap because the expensive version was just ordinary chemistry in a better-looking bottle.